Okay, here's your video screencast on imaginary numbers and arithmetic with complex numbers, which contain imaginary numbers. The purpose of this video is to introduce you to this new type of number system with a -1 underneath a square root. And I'm going to show you a little bit about how to do arithmetic, plussing, minusing, multiplying, dividing with these types of numbers. So here we go. I'd like to start off the video by asking you to consider these two problems below. What values could we have for x? And the real good way to approach this, it's kind of funny, type of problem is to ask yourself what times itself is 9? What times itself is 9? And down here, what times itself is -9? So let's do this first problem. What times itself is 9? Well, I can think of 3 different ways to represent x. X could be +3, because 3 times 3 is 9. X could be -3, because -3 times -3 is 9. And the third way I can think of is x could equal the square root of 9. And the reason I'm making that jump is to show you why the next problem works, but also just to make a point that the square root of 9 times the square root of 9 is 9, because the square root of 9 times the square root of 9 is 9. Square root of 9 squared, square root of 9 squared, which just gets us back to 9. So notice that this could be a solution, this could be a solution, but this could also be a solution to x. So then in this problem, what times itself is -9? Well, I know it's not 3, and I know it's not -3. It couldn't be 3 times -3, because that's not x squared. This is not the same as -3. So the only other way to represent this would be that -9 is equal to the square root of -9 times the square root of -9. So what do I do with this -9? If I'm telling you that this is a possible solution, the square root of -9 is what x equals, this is kind of messy, the square root of -9. So what mathematicians have done is decided, okay, well, if I have the square root of a negative number, I can break that up underneath the radical, right? That square root is called the radical. And then from there, I can break up the radical. This can be turned into the square root of 9 times the square root of -1. You learned this at some point in your math education in the last, 10 years or so, but you might have forgotten that you can do this. So now all I have to deal with, because I know that the square root of 9 is ±3, I'm familiar with that number. So now really it just boils down to dealing with the square root of a -1. So no matter what problem you give me, I can break it down to be something like this. So what do we do with this? What do we do with this -1 underneath a radical? Well, let's give it a name. Let's call it I. And the nickname for this is imaginary numbers. So make a note of that. Okay. So how do I write ±3 squared root of -1? Because this is what x equals if you have this problem. That's supposed to be a negative sign and a 9. X equals ±3 times the square root of -1. That is the solution to this problem. So this is either +3 times square root of -1 or -3 times square root of 1. And from your note you just took, you learned that the square root of -1 is I. So the solution to the problem is 3i or -3i. And this is how mathematicians have cleaned it up for us. So instead of calling it this, we call it 3i or -3i. Okay, one more note. Oh, what? No, first, multiple choice question. Here I'd like you to solve for x squared plus 4 equals 0. I have worked out the problem here for you. Please pause the video and make a note of this. This is your multiple choice question for the quiz. Okay. One more definition. So we have real numbers and we have complex numbers. Real numbers are the numbers that you have grown up with. 1, 2, 3, 4, 5, 1/2, 3/4. Pi is a real number. E is a real number. All these things are real numbers. Once we start getting into the world of imaginary numbers, and that's the nickname for them, we really want to talk about complex numbers. Because complex numbers are any number in the form a plus bi. So 3 minus 4i contains an imaginary number. We call this a complex number. Okay, so just write that down and I'll take questions in class about that. and I'll explain a little bit more. What I want to do for the next couple minutes is show you how to do arithmetic with complex numbers. So first let's do addition. Here are two complex numbers containing imaginary numbers, and how you add them is just like how you would add binomials. You would combine like terms. We have a 2 and a negative 4, and a 3i and an 8i. Combine like terms, you get negative 4 plus 11i, and that is the answer. This is how you add complex numbers. So when you add two complex numbers, you get a complex number. Subtraction is the same way. Combine like terms. 2 minus negative 4 and 3i minus a positive 8i gets you 6 minus 5i. It's just combining like terms. So addition and subtraction are pretty straightforward. Multiplication is a little tricky. This is a number in complex numbers. Like that is considered a number, just like 5 is considered a number. So how do you multiply two numbers that look like this? Well, you do it just like you would a binomial. Use a generic rectangle, fill out the insides, rewrite it as a sum. And the only other step here that I'd like you to make a note on right now is that if I is equal to the square root of negative 1, then I squared is equal to negative 1. If you need to pause the video and think about that for a second and convince yourself that's true, please do that now. Okay, so if I squared is equal to negative 1, then I can do a little substitution here, right? I squared is negative 1. So now I get just negative 8 plus 4i minus 24. Combine like terms, and you get negative 32 plus 4i. So in complex arithmetic, the goal is to get a number answer that looks like a plus bi. That's kind of the point. So when we divide, the point is to get this into the form a plus bi, and that's what we're going to do in class because I think this is a good stopping point, and that way I can interact with you guys and answer some questions. Please complete the quiz, and I'll see you in class.